Hello everyone. So welcome back to the most important topic of matrices, जो कि है characteristics matrix. So apart from characteristics matrix, we'll also get to learn what is characteristics polynomial, characteristic equation, and then what are characteristics vectors or eigenvectors. And we'll try to find some characteristics roots or eigenvectors here. So it's very important topic, characteristics matrix. So what is characteristics matrix? तो for characteristics matrix पहले हमें क्या चाहिए? We need a square matrix. Okay, so that may be of any order. So यहाँ पे हम लोग यहाँ पे लिखा था the order is what? N. So what is capital A? Capital A is a square matrix of order n, and then with that we need one identity matrix also, मतलब unit matrix. उसका भी order क्या होना होगा? N. So capital A is a square matrix of order n. Capital I is also a unit matrix of order n. Then A minus lambda into I. So now this is a new matrix. Now what is lambda? Lambda is a constant. Okay. Then A minus lambda into I is called characteristic matrix. Okay. So it's very simple. A minus lambda into I. Now what is lambda? Lambda is an indeterminate. Okay, so that is a constant. In problems we can find the value of lambda. Okay, so later we will discuss about that. So ये होगी characteristics matrix. So बहुत ही simple है. A minus what? Lambda into I. Only this particular new matrix is called characteristics matrix. A minus lambda into I. A is a matrix, square matrix, capital I is identity matrix. Okay, identity matrix, and lambda is a constant. In place of lambda we can use any other constant also. Now what is characteristic polynomial? Characteristic polynomial. So when you say polynomial, no, polynomial means, polynomial is what? Polynomial is a expression, but this is a matrix. When we say A minus lambda, this will be a matrix. But what is characteristic polynomial? So determinant A minus lambda I. So above is a what? Above is a matrix. Now if we take the determinant and if we expand this determinant, what you will get? You will get a expression. In example I'll show everything. So this is the polynomial. This is called characteristics polynomial. Then comes characteristics equation. Characteristics equation. So equation means what? There will be right hand side now. So the above one is polynomial. A minus lambda I is a polynomial. Now if we set the right hand side as 0, now this will become an equation. Okay, so A minus lambda is characteristics matrix. Determinant A minus lambda is a polynomial, and determinant A minus lambda equal to what? 0 is characteristics equation. Now when we say equation, so if we solve the equation, we'll get some values. So here which is unknown? Here lambda is unknown. So now after solving this characteristic equation, we'll get some what? Values of lambda. Okay, those values are called characteristics root or eigenvalues. Okay, characteristic roots or eigenvalues. Now the roots of the equation, determinant A minus lambda I equals to 0 are called characteristic roots or eigenvalues. Okay, sometimes we call them as proper values also. So okay, it's very simple. Determinant A minus lambda I equals to 0 is an equation. When you solve this equation, we'll get some values of lambda. कुछ lambda का value यहाँ पे आएगा. ठीक है, if the matrix is 2 by 2, अगर 2 by 2 है, तो we'll get 2 values of lambda. और अगर जो matrix है वो 3 by 3 है, then we'll get 3 values of lambda. ठीक है, तो हम लोग 2 by 2 और 3 by 3 जो matrix है, उसका जो solution है, वो बाद में हम लोग निकालने का यहाँ पे कोशिश करेंगे. So in this particular lecture, so we'll try to find the value of lambda for 2 by 2 matrix, and then if possible then I'll take one 3 by 3 matrix also. Okay, in the next lecture we'll try to learn what is characteristics vector or characteristic eigenvector. Okay, that is one of the most important thing again, characteristics vector और eigenvector क्या है. Now कैपिटल ए पहले जैसा स्क्वायर मैट्रिक्स है. ओके, स्क्वायर मैट्रिक्स ऑफ ऑर्डर n, ठीक है, ऑफ ऑर्डर n. देन लेमडा, लेमडा ऑलरेडी हमें यहाँ पे मिल चुका है. ओके, कैरेक्टरिस्टिक्स रूट, कैरेक्टरिस्टिक रूट, ठीक है. तो यहाँ पे लेमडा चाहिए. अभी जो यहाँ पे हम लोग लास्ट जो यहाँ पे जो डेफिनेशन जो देखे थे, सो वहाँ पे क्या था, लेमडा का वैल्यू हम लोग निकाला था. ठीक है, द वैल्यूज ऑफ लेमडा आर कॉल्ड कैरेक्टरिस्टिक्स रूट्स, बट हियर वी ऑलरेडी नो व्हाट इज द वैल्यू ऑफ लेमडा. ओके, दैट वी नो. सो ए इज ए स्क्वायर मैट्रिक्स ऑफ ऑर्डर n, लेमडा क्या है, कैरेक्टरिस्टिक रूट. एंड देन हमें एक और एक मैट्रिक्स चाहिए, लेट कैपिटल एक्स बी ए नॉन जीरो column matrix. Okay, non-zero column matrix of this particular type. See, suppose capital X equals to ऐसा आएगा x1 x2 then dot 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 xn. Why n? Because the order is how much here, n. So if it is a 2 by 2 matrix, then capital X will, in capital X will take only two elements, x1 and x2. If it is a 3 by 3 matrix, then in capital X will take three elements, x1, x2 and what, x3, but within one column. Okay, so capital A x square matrix है, lambda क्या है, characteristic root है, and capital X is a column matrix such that ax equals to lambda x. So this is a new equation. If capital X satisfies this particular equation, okay, if capital X satisfies this particular equation, ax equals to lambda x, then x is called characteristics vector. Characteristic vector or eigenvector. Okay, और eigenvector. ओके, सो यहाँ पे जो कैपिटल एक्स है उसको हम लोग बोलेंगे कैरेक्टरिस्टिक्स वेक्टर और आइगन वेक्टर. कैपिटल ए विल बी नोन टू अस, लेमडा का वैल्यू हम लोग खुद निकालेंगे, एंड देन विल फाइंड कैपिटल एक्स व्हिच इज कॉल्ड कैरेक्टरिस्टिक्स वेक्टर और आइगन वेक्टर. ओके, नाउ लेट अस टेक ए सिंपल प्रॉब्लम सो दैट वी कैन फाइंड द कैरेक्टरिस्टिक्स रूट्स. फॉर एग्जांपल, सपोज कैपिटल ए इक्वल्स टू 1, 3, 4 and 5. So this is a 2 by 2 matrix. Now how to find the characteristics root? For finding characteristics roots or eigenvalues, we have to solve the characteristics equation. So what is the characteristic equation? A minus lambda equals to 0. So this implies determinant. Our A is how much? 1, 3, 4 and then what? 5. Minus lambda into what is I? I is 1, 0, 0, 1, identity matrix. Determinant close equals to how much? 0. Now we can write within one determinant. So what will be the first element? 1 minus lambda, then 3 minus lambda into 0 is 0, 4 minus lambda into 0 is 0, and then again 5 minus lambda. Okay, 5 minus lambda. Now after that what to do? You have to break this particular equation. Okay, so if we break it, what we will get? 1 minus lambda, 5 minus lambda, 0. So okay, so यहाँ पे lambda का दो वैल्यू आएगा 1, 5. So these values, no, 1 and 5. Okay, sorry, थोड़ा सा यहाँ पे mistake हो गया. This will be 3. Sorry, this will be our 3 and this will be our 4. Okay, so it's 3 minus. So it will be 3 and this will be what? 4. तो यहाँ पे और एक equation आएगा, यहाँ पे और एक term आएगा, this into this minus how much? 12. Okay, equals to 0. Now let us break it. So it will be how much? Lambda square then minus 5 lambda, so minus 6 lambda plus 5 minus 12 equals to 0. So lambda square minus 6 lambda minus 7 equals to 0. Okay, so this one after factorization, what we can write? We can write lambda plus 1 lambda minus 7 equals to 0. Okay, so अगर आप लोग इसको फैक्टराइज करेंगे तो ये दो आएगा. So after solution, after calculation, what will be the values of lambda? Minus 1 and 7. So these are called what? Characteristics roots or eigen values. Okay, characteristics roots or eigen values. So बहुत ही simple है. Whatever matrix is given for that particular matrix, first we have to take the characteristics equation and then simply we have to solve it. Okay, so in our next lecture we'll try to find characteristics vector of 2 by 2 matrix and characteristics vector of 3 by 3 matrix. Okay, because if I include those in this particular lecture, then the lecture will be very, very long. So let us split it into 2 other videos. So after this particular video, I'll make one video where we can find characteristics root and characteristics vector of a 2 by 2 matrix, and then we'll try to find characteristics root and characteristics vector of a 3 by 3 matrix. Okay, so I hope the characteristics matrix and the characteristics polynomial, these things are clear to all of you. And if you like my video, kindly share with your friends also, and thank you for watching.